Picture a flawless, shimmering pearl in your mind. For centuries, we've treasured this tiny sphere as the ultimate symbol of beauty and purity. But we rarely stop to think about the highly sophisticated microscopic world that actually creates all that beauty. So today, in this explainer, we're diving way past the surface of the pearl. We're going to explore a hidden realm of structural engineering that is so advanced, human scientists are literally just now figuring out how to copy it. Let's get right into it. Which brings us to a really fascinating mystery to kick things off. Where does this glow actually come from? We all know pearls have that mesmerizing, shifting luminescence when you hold them up to the light. But for the longest time, the actual source of that visual allure was a total mystery to us.
Section 1. The Pearl's Hidden Secret.
To unlock this glow, Dr. Ryotaro Ozaki and his team over at Ehime University went microscopically deep into the pearl's material, which is known as nacre, and they made a truly groundbreaking discovery. It turns out that glow, it doesn't come from pigment at all. Nope, the oyster isn't painting the pearl. Instead, it's actually a brilliant optical illusion created by precisely engineered nanolayers. So as the thickness of these tiny microscopic layers shifts, it manipulates the light on a nanometer scale, and that is what actually alters the colors we perceive. Kind of mind-blowing, right?
Section 2. The two faces of calcium carbonate. To really grasp the paradox of how these tiny optical layers are built, Professor Mark McKee at McGill University offers us a perfect perspective. He points out, everyone thinks eggshells are fragile. Actually, depending on their thinness, they are extremely strong, harder than some metals. It's a fantastic point. In the microscopic world, extreme thinness can actually result in some incredibly surprising structural integrity. To put that into perspective, think about a piece of standard blackboard chalk. If you drop it, it's highly fragile, right? It just shatters into dust. Now, compare that to nacre, the material of our pearl, which is incredibly strong and nearly unbreakable under normal pressure. Here's the real kicker, though. Both of these are made of the exact same ingredient. They are both over 90% calcium carbonate, literally the same stuff. But when a mollusk takes that exact same, highly fragile material and organizes it, the resulting nacre is an astonishing 3,000 times stronger than standard chalk of the exact same size. 3,000! I mean, how in the world is a simple sea creature achieving an engineering feat of this magnitude?
Well, Dr. Robert Hovden from the University of Michigan explained this mechanical marvel for us. When a heavy impact or stress hits the shell, it doesn't just crack. Instead, these nanometer plates physically slide against each other and they lock together. This distributes the force so the entire structure doesn't shatter. And then, once the threat is gone and the force is removed, those microscopic plates safely unlock and just return to normal. It is essentially dynamic, active armor.
Section 3. Science mimicking nature.
So once scientists figured out how these sliding nanopleats were absorbing all this stress, they obviously scrambled to copy it. Researchers back at McGill University actually cracked the code. They successfully mimicked the pearl's nanostructure to engineer a revolutionary new type of strong glass. They quite literally copied the homework of an oyster to solve a modern engineering problem. And the success of this biomimicry? It's staggering. This new nature-inspired glass is a massive 5 times more durable than normal glass. Just by organizing the structure the exact way a mollusk does, the durability completely skyrockets.
Section 4. The true source of this miracle.
If we step back from the microscopic science for just a second, I want us to consider how a pearl is actually formed in the first place. When a foreign, painful irritant gets trapped inside the shell, the mollusk doesn't just isolate it. As a defense mechanism, it actually transforms that painful irritant into a structural masterpiece of glowing nanotechnology. It literally takes a flaw and turns it into a flawless gem.
This brings a really beautiful theological perspective into view, perfectly captured in the Quran. Surah Ar-Rahman, verse 22. From both of them emerge pearl and coral. You see, this awe-inspiring miracle of structural engineering, a fragile chalk-like substance reorganized to be 3,000 times stronger. This existed perfectly in the depths of the ocean for ages, way before human beings ever even coined the word nanotechnology. Which leaves us with a pretty profound question to wrap up this explainer. Who taught this highly advanced nano-organization to a simple mollusk? Think about it. Human scientists with advanced degrees and million-dollar labs are only just now learning to copy this exact blueprint to make stronger glass. Yet this humble creature has been successfully executing nanometer-level architecture for countless ages. It really challenges us to look beyond just the mechanics and marvel at the grand hidden designs in the natural world.